Hello, hello, going over some homework from Algebra 2, Chapter 10, Section 2, Probabilities of Independent and Dependent Events. Here's question 22. The table shows the number of tropical cyclones that formed during the hurricane season over a 12-year period. Find the probability, here we go, I'm going to put a little letter A right here, to predict whether the weather be hot, whether a future tropical cyclone in the northern hemisphere is a hurricane, and B, the probability to predict whether a hurricane is in the southern hemisphere. Okay, and so let's see. Part A, probability about whether a future tropical cyclone in the northern hemisphere is a hurricane. So it seems as though my possible outcomes: tropical cyclone in northern hemisphere are the possible outcomes. So tropical cyclone. Okay, so all of these, all right, forgive my not knowing weather terminology. All of these are in the category of tropical cyclones. All right, and I'm looking at the ones that are only in the northern hemisphere. And so actually, you know what? Here we go. I'm going to do it again. I'm going to copy this table twice. So that way I can draw over it a bunch. Boom. All right, so for part A, this is what I'm considering. And so for my denominator, I've got a hundo plus 342 plus 379 is my denominator. The numerator is which of these are hurricanes? Yeah. And so I would be looking at just the 379. And so if I add them up, I get 379 over 821, which is about 46.2% of northern hemisphere tropical cyclones are hurricanes. Whew. It's quite a bit. Quite a bit. All right. Interesting. Let's see. Then, part B, find the probability to predict whether a hurricane is in the southern hemisphere. And so this time, all hurricanes are my possible outcomes. And so this would be 379 plus 525. And my numerator are southern hemisphere ones. Southern Water Tribe, right? Avatar: The Last Airbender reference. 487. Boom. And so here's part B. Simplify this a tad. Did I do this one wrong? Ah, I did. This isn't even in the sample space. Rip. All right, so 525 is my numerator. And once again, this is B. And I got, this simplifies to be 525 over 904. And so that's about 58.1%. And so what was this? This was, of all hurricanes, what percent of them are in the southern hemisphere? Or what's the probability they're in the southern hemisphere? Okay, all right, so that works. I liked that change in the. I was expecting I was gonna have purple right here, but no, sir. I'm liking it. All right, at a gas station, 84% of customers buy gasoline online. What? No. Buy gasoline. I saw O-line and I don't know, my brain went crazy. Buy gasoline. I don't think you can buy oh, I guess, I don't know. Who knows? Buy gasoline. Only 5% of customers buy gasoline and a beverage. What is the probability that a customer who buys gasoline also buys a beverage? So what's the probability of a beverage purchased given they also purchased gasoline? All right. And so this is my B and A. So this is equal to the probability of A and B occurring divided by the probability of just gasoline purchased. Okay, and so probability of A and B is right here. That's the 5%, so 0.05. And the probability of just buying gasoline is 84%. And so, 8, 4, and equals. And so this is approximately 6%. Boom. So 6% of gasoline purchasers also bought a beverage. All right. I'm thinking about the number of times I buy fuel, and very rarely do I buy a beverage. So yeah, that seems reasonable to me. Okay, here we go. Question 25. I really liked this this question. Gets you thinking. You and 19 other students volunteer to present the Best Teacher Award at a school banquet. One student volunteer will be chosen to present the award. Each student worked at least 1 hour in preparation for the banquet. You worked 4 hours. And the group worked a total of 45 hours. So you worked 4, each other student worked at least 1, and there were 19 total students. Lots of information going on here. Okay. All right, 19 other students. So 19 plus you, thank you, by the way, for all your hard work, is 20 students. Okay. All right. For each situation, describe a process that gives you a quote-unquote fair chance to be chosen. By the way, I did do air quotes with my fingers, even though I'm not on the video visible. So there we go. All right. What if fair means equally likely amongst all students? All right. And so what would you do? Well, if it was equally likely amongst all students, you would take, right, 20 students, of which you are 1, and that is about a 5% chance of success, right? So you would just say, hey, let's pick amongst the 20 students. Now, there's another way you could have defined fair in this situation, which in this case works in your favor. What about fair meaning proportional to the number of hours each student worked in preparation? And so what's the total number of hours that people worked? So total of 45 hours instead of students. And how many hours did you work? Well, you worked 4. And so basically, instead of comparing it to the number of students, you're looking at number of hours worked. And so what you'd be doing in this situation is you'd have 45 pieces of paper placed into a hat or something like that. And then each student would get their name on a piece of paper based on the number of hours they worked. So you would have had 4 pieces of paper in there. Some other students would have only had 1, others might have had more, etc. And so your name is on 4 of those pieces of paper. And as a result, those are the number of successful ways you get picked, and that would be about an 8.9% chance of success. Now, you could argue an even fairer way, possibly, is what if you had down to the minute, right? Because, I mean, these were broken up into hours, right? Maybe some people, what if someone worked 1 hour and 59 minutes versus someone working 1 hour and 1 minute? They might argue differently. But anyways, so this is an interesting kind of problem to evaluate this situation. I don't know, YouTube, blah, blah, blah. Let me know in the comments below which you think is fairer. Who's the fairest of them all? All right. Well, anyways, thanks for watching. Have a great day.